This video is going to go over topic 5, section 7, day 2. Topics or 5.7 is exponential log equations. Today we're looking at just logarithmic equations. So remember that a logarithmic equation is an equation that contains one or more logarithms of variable expressions, meaning that the variable is inside the log. The property of equality for logarithmic equations that we're going to be using today is the forward direction. So if x is greater than 0, then log base b of x equals log base b of y if and only if x equals y. So what this means is that if our two logs have the same base and they're equal to each other, then the quantities are equal. So the values inside the log can be set equal to one another. One thing that we have to be careful with in this lesson is extraneous solutions. So remember that extraneous solutions are solutions that arise through inverse operations that are not actually solutions to the original equation. For logarithms, the argument, which is the value inside the logarithm, must be positive. And so what that means is that if I'm checking my answer, I need to have log of a positive number. That's good. However, when I check my answers, if I have log of 0, that's not good. And if I have log of a negative number, that's not good. So those two situations produce an extraneous solution. Okay, so I am plugging the answer back into the original problem that was given and checking to see if that produces positive log equal to positive log, so that I know that it is a true solution. So for this first example, we have a natural log of x squared minus 16 equals a natural log of 6x. So since they both have natural logs, those share the base of e, I can take the arguments and set them equal to each other. So that means that I have x squared minus 16 is equal to 6x. So just like we ignored bases when they are the same, we can ignore logs when they are the same, as long as it's just log equal to log. So one thing to note is that since this is a quadratic variable, remember that we want to keep our x squared term positive. And solve. So the other side is 0. And then we're going to use factoring. Or if you wanted to, we could use the quadratic formula to get the answers. So if you are wary on factoring, you can always use quadratic formula, and that'll work each time. So in this case, my x squared term is positive on the left, so that means that I want to leave it there. So I'm going to subtract 6x from both sides. Remember that this might just be rearranging where I don't have any like terms that I can actually combine. And so this is the case here. And I want to write it in standard form. So I have x squared minus 6x minus 16 is equal to 0. So then when I'm factoring, that means that I want to use a product sum table. So to get my product, I'm taking the first coefficient and the last coefficient, so a and c, and I'm multiplying those together. So 1 times negative 16 is negative 16. So I want to factor negative 16 so that the two numbers add to negative 6. Okay, so I'm looking at factors of negative 16, which are 1 and 16, 2 and 8, and 4 and 4. In order for them to add to a negative, the larger numbers would have to be negative. And so if I look at those factors, 2 and negative 8 create a sum of negative 6. So 2 times negative 8 is negative 16. 2 minus 8 is negative 6. So that means that those factor to x plus 2 times x minus 8 equals 0. So when I'm solving this, what I have to do is take each factor and set it equal to 0 individually. So remember that there is a shortcut for this, and we'll do that in the following problems, but for this one, we're just going to do it following the whole procedure. So x minus 8 equals 0. And so if I were solving these, I would do the opposite. So I have x plus 2, so I'll subtract 2 from both sides. So that gives me x equals -2, and then adding 8 to both sides, that gives me x equals +8. So remember, the shortcut is when I have this x plus 2, I just change the sign on the 2, and that's my answer. X minus 8, I change the sign on the 8, and that's my answer. So remember that our final step is that checking for the extraneous solutions. And so we're going to check to make sure that these values have positive arguments. Okay, so I'm checking in the original problem. And so that original problem is I have ln of x squared. I'm going to start with the -2 minus 16 is equal to ln of 6 times -2. Notice that this is -12, and I'm not allowed to have that negative inside a log, so that means that that's extraneous. Okay, so -2 is an extraneous solution. Let's see if 8 is an actual solution. So we could have 2 solutions for this, 1 solution, or none, depending on how these numbers check out. So ln of 8 squared minus 16 equals ln of 6 times 8. So 6 times 8 is 48. So we're looking at making sure that this also equals 48. So 64 is 8 squared minus 16. So that's ln of 48. Notice I didn't check the other side for the first one, because as soon as one side is negative, that means that that's not going to work. So that means that our only solution for this problem is that x is equal to 8. Okay, so I do have to check both sides if I get a positive on the first side. If I get a negative on the first side, I'm good. It's not going to work on the other side either. Okay, so this next problem is going to follow the same exact process. We're just getting a little bit of practice. The last one is a little bit more complicated just in terms of factoring. So we have log base 5 of x squared minus 45 is equal to log base 5 of 4x. Since those both have a log base 5, we can then ignore the log and just set the arguments equal. So x squared minus 45 then must be equal to 4x. So since x squared is positive on the left-hand side, let's subtract 4x from both sides. And so that gives us x squared minus 4x minus 45 is equal to 0. And from there, we want to do a product sum to determine the factors. So remember that we're multiplying the leading coefficient by the constant. So 1 times -45 to get -45. When we're factoring this, we're thinking about all the possible numbers. So it's always 1 and the number. 3 times 15 makes 45. And then 5 times 9 makes 45. So those are all the possible factors of 45. These need to add to the coefficient on x, which is -4. So in order for that to happen, I would need the larger number to be negative. And so the one that works is 5 and 9, -9. So that means that I can use this as x plus 5 times x minus 9. So remember that going straight from the product sum table to the answers is only happening because of this leading coefficient of 1. I forgot to mention that on the previous problem. So because this number is 1, because this number was 1, we're able to just write the answer as opposed to having to do a full grouping problem. That will change in the next one. Okay, so then we talked about the shortcut. So the first shortcut was being able to do this and to not have to do grouping. The next shortcut is knowing that that means that this expression means x would have to be -5 because I have x plus 5, right? So -5 would turn that into 0. And that this one means that x would have to be +9. Our final step is to check those answers to ensure that they are actually true from the original problem. So if I go ahead and check, I'm going to plug them into log base 5. And then I have x squared minus 45. So -5 squared minus 45 is equal to log base 5 of 4 times -5. So again, this one, if I look at the one that's easier, that's going to give me log of -20. Because that's negative, that's not a solution. So this one is extraneous. So -5 is the extraneous solution, or a extraneous solution. These could both be extraneous. And then x equals 9, so our new log base 5 of 9 squared minus 45 equals log base 5 of 4 times 9. So that's 36. So we need to make sure that 9 squared minus 45 is also 36. So remember that 9 squared is 81. 81 minus 45 is 36. So log base 5 of 36 on both sides means that that is a valid answer. So our answer for B is that x must be equal to 9. For our final problem, we've got on the backside ln of -4x minus 1 is equal to 2 ln of 2x. So what is different about this problem is that I don't have just a log equal to a log. So I do actually need to use the power property in order to isolate my log. So I have to start by using the power property and move that coefficient to become an exponent. So that means that I'm going to rewrite this as ln of -4x minus 1 is equal to ln of 2x all squared. So now that I have just a natural log equal to a natural log, I'm going to take and ignore that and rewrite everything else as an equation. So that means that I have -4x minus 1 is equal to 2x squared. So in order to simplify this, that means that I need to actually square 2x. So I have -4x minus 1, 2x. Remember that that means that I'm doing 2x times 2x. That's going to become 4x squared. On the assignment, you will have something like if I had 2x plus 1 times 2x plus 1, I would have to distribute that. So I would have to do 2x times 2x is 4x squared, 2x times 1 is 2x, 2x times 1 is 2x, 1 times 1 is 1. So remember that you will have to do that on at least one of the assignment problems. So just a reminder that when I'm squaring, I want to write it as whatever's inside the parentheses times itself, and then I might have to double distribute there. So remember that our goal here is that the x squared term is positive. So currently the x squared term is positive. So that means that I want to keep it there. So I'm going to move the other two terms towards it. So that means that I'm going to add 4x and I'm going to add 1 to both sides. So add 4x plus 1. Again, I'm just rearranging so that I have 0 on one side. Normally, we would move the least amount of terms over, but it's important that a is positive, that leading term is positive in order to factor. Okay, so from here, we're going to do our product sum table. And so in this one, our a is 4 and our c is 1. So we're going to multiply 4 times 1. So that means that we need two numbers that multiply to 4. This is nice because 4 only has two sets of factors, 1 and 4 or 2 and 2. Those two factors need to add to 4. And so 1 plus 4 is 5. 2 plus 2 is 4. So that means that it's 2 and 2. Notice that we can't do x plus 2 times x plus 2. Okay, so x plus 2 times x plus 2 would not multiply to 4x squared plus 4x plus 1. Okay, so we cannot use that shortcut that we used. We actually have to do grouping. So remember that with grouping, we're going to take our first term and our last term, and they're going to stay as they are, and then we're going to use these terms to split up our 4x. So our 4x is now going to be 2x plus 2x. So again, this term here splits using the values from our product sum table. So we are completing this using grouping. And so when we're grouping, what we want to do is factor out the greatest common factor between the two terms. So 4x squared and 2x have a common factor of 2x. And if I divide those, 4x squared times 2x makes, 2x times 2x makes 4x squared, and then 2x times 1 makes 2x. So we're dividing both of these terms by that 2x, right? So 4x squared divided by 2x gives us 2x. 2x divided by 2x gives us 1. For this one, we also, remember, we want to get that 2x plus 1 left over. What's important to note is that we already have that. So that means that the common factor here is just 1. You have to make sure that you write it because that's part of one of the factors. So that means that this guy factors to that common factor, 2x plus 1, times the sum of the coefficients. So if I'm factoring that out, I end up with 2x plus 1. Okay. So what this means is that my solution is actually a perfect square. So it's something that will have a multiplicity of 2. I get the same answer twice. So if I were to take this and set it equal to 0, then I would have to subtract 1 from both sides and divide by 2. So if I subtract 1 from both sides, 2x equals negative 1. And then divide both of those by 2. I get that x equals negative 1/2 with a multiplicity of 2. And so what I need to do now is check that single answer to make sure that it works. So in my original problem, we're going to plug into ln of negative 4x minus 1 equals 2 times ln of 2x. ln equals 2 ln of 2 times -1/2. So if we simplify this, we get ln of, so -4 times -1/2 is +2. So then 2 minus 1 is 1. So we get ln of 1 equals 2 times ln of -1. And so what happens is that because I have ln of +1 equals ln of -1, this one makes it so that this cannot be a solution. And so since it was my only option, that means that this problem has no solution. So remember that for these problems, what we're looking for is to identify values that are solutions to the part inside the ln. However, we have to check back to make sure that that doesn't create those values as negative, because if they are, that means that they have extraneous solutions.